Hello students. So far we have been talking about tangents, isn't it, and the application of calculus on tangents. With that being said, I always like to differentiate between these. So let's say you have g of 3 is equals to 5, right? And g prime of 3 is equal to 5. By now you should know the difference between these, that this one here, right, it means when x is 3, the y value is what? Is 5. So this would be your x, and then this one will be your what? Your y value. But this one here means at a point, at a certain point, that point the x value is 3, but we do not know the y. The gradient of the tangent, right? The gradient of our tangent would be equal to what? Would be equal to 5. So this means at x is equals to 3, the gradient is 5. At x is equals to 3, the gradient of the tangent is equal to what? To 5. I hope that is clear there, right? So remember, if I were to have a function like this, if I put a point here, I can have a tangent. Then if I can find the derivative of, let's say this is f at x, if I can find the derivative of f at this point, at that x value, I will get the gradient of the tangent at that x value, at that point, okay? So also, we need to remind ourselves that if I have, let's say I know that the equation of a tangent, let's say we have another tangent here. Let's say I know that the equation of this tangent is x plus 6, right? And then let's say the point here is 3 is to y. We know that if this is the equation of the tangent, okay? If this is the equation of the tangent, remember a tangent is a straight line, so this is the equation of a straight line. If I'm given the equation of a tangent, I can substitute the x value to say g of 3, I'll get 3 plus 6, which is 9, which means I would get that when x is 3, y is 9, I would get the y value to be 9 if I substitute the x value into the equation of the tangent. But also, let's say this was f at x, right? And I'm given that f at x is equals to x squared. If I substitute 3 at the x value, which is 3, into the equation of f, meaning into the equation of the function, if I can substitute 3 to say f of 3 is equals to 3 squared, I'm gonna get 9, which is 3 is to 9, right? So let's understand that substituting the x value into the equation of the tangent will give you a y value that is the same as substituting the x value into the function. It's gonna give you the same y value. Let that be clear, right? If we check our previous video, you will then understand that that is how we solved the solution there. Now let's continue and look at some more questions on this, right? We are given here that the tangent to a curve, right? They say the tangent to a curve is perpendicular to this line G at x is equals to 1. Now, line G makes an angle of 45 degrees with the positive x-axis, and g of 0 is equals to that. Alright, for us to solve this problem, let's take it step by step. But in this case, let's actually look at G and try to imagine what line G would be looking like. I'm assuming line G is just a straight line. So let's have our Cartesian plane, right? Let's say this is our Cartesian plane here, and then right, we can say this is our y-axis here, right? And then let's say this is our x-axis there, right? And then our 0 is there. Now, first of all, here what are we given when they say g of 0 is equals to negative 8? Students, what do we mean by this? Do we have a prime? No, there is no prime there. It's just g of 0. So this means when x is 0, y is what? Is negative 8. When x is 0, y is what? Negative 8. Which point is that? it's a point that will be somewhere here, right? We can say x is 0 here, and then y value is -8. Okay, then we are also told that line G makes an angle of 45 degrees with the positive x-axis. The positive x-axis is this part, good people, okay? And then the negative x-axis is this part, because they are negative numbers. So line G makes an angle of 45 degrees with the positive x-axis. So it tells us that line G is something like this. So that will be line G here. And here, good people, let's understand that this angle, what will be that angle? The angle would be 45 degrees. Okay, that would be 45 degrees. So this is G of x. That is line G. Why am I starting with line G? Because it will help me to understand the relationship between line G and the tangent. Okay, so now let's also remember that that line G will be sharing the same point with the tangent. Okay, what am I saying? We were told that at x is equals to 1, we're talking about at x is equals to 1, this line is perpendicular to the tangent. So let's have a line that will be perpendicular to this. A line that will be perpendicular to that will be looking like this, right? I'm gonna do my best to draw this. This would be a line that is perpendicular to G, this line here. If I do it like this, yeah, they're definitely perpendicular to each other, isn't it? Sorry, they're perpendicular to each other. So we have something like this, then we have something like that. So we say they are perpendicular to each other there. And then this point, right, this point here, at that point the x value would be 1. So this is our tangent here, right? This is the tangent. And then at this point x will be 1. We have our function there, right? The function is a cubic function, so maybe it could be something like maybe let's have this, right? We could say maybe it's something like, let me try to visualize it. Maybe it's something like this and then like that, you know, you never know. Maybe it's something that is looking like this. Yeah, maybe it's something, because it is positive, so but it doesn't really matter. No, wait, it cannot be like that. Remember, a tangent doesn't cross like this. Let's just say maybe how will it be like? Well, I cannot completely visualize what f would be like there, because let me think a bit. Okay, so I know that we have not talked about cubic functions, since that is the next video that we'll be looking at, right? In the next video I'll be taking you through cubic functions and their shapes and the likes. But just to give a bit of a heads up, if a cubic function has a positive a value, it means the shape is like this, right? It means the shape is like this. So this means here I can say maybe the graph would be looking like this, and then like this, and then maybe like that, right? Okay, now let's draw it nicely. It will be something maybe like this, and then maybe like that. Okay, so that could be your function there. This could be f at x. Okay, then this line here, this point, at that point the tangent is touching the graph at this point there. Well, yes, we know that it's also touching here, but the main point that we'll be focusing on would be this one. Okay, so we have our tangent line, we have G, right? We know that at this point the x value is 1, but we do not know the y value. Okay, now what do they want? Let's understand also that this point is the point of intersection of G at x, tangent, and f, meaning that point belongs to the graph of G, and also it belongs to the graph of the equation or the graph of the tangent, and also it belongs to the graph of G. Okay, so if you substitute x as 1 in the equation of the tangent, the y value that you get is the same as if you substitute x as 1 into the equation of g at x. And the y that you get is the same as when you substitute x as 1 into the equation of f. Are we clear? You get the same y value because that point, they all share it, those graphs. So what was the question asking us of there? They say calculate the values of p and q. So they want p and then they want q, isn't it? Let's be very, very careful there, right? Let's be very, very careful. Now, the first thing we're gonna talk about is to say, what do we know about the graph of G? The graph of G, do we know its equation? No, we don't know the equation, isn't it? And we only have 1 point. If we had 2 points, we could use those points. Remember now that formula applies when you have 2 points. Then we could use these to get the gradient, isn't it? If we have 2 points on G. But in this case, we only have this point, and then we have this point, we are missing the y value. So what do we do? Well, let's remember that in analytical geometry, the 45 degrees, right? In analytical geometry, the 45 degrees tells us that we can use it to get the gradient. We call it the angle of inclination, right? So to get the gradient of the G, we can say m of that line, or m of G, the gradient of that line, would be equal to tan theta. Okay, so this means the gradient of that line would be equal to tan 45 degrees. Let's understand that as much as we're doing functions or we can do calculus, all the concepts, they come together. Okay, don't forget any concept. We don't treat concepts in isolation. So the gradient of that line, right, the gradient of that line would be tan 45. What is tan 45? Tan 45 is 1, right? So you have the gradient of that line is 1. Now that we have the gradient of that line as 1, most definitely we can find the y value, isn't it? Yes, we can get the y value because now we know the gradient. Yes, so this is what we can then do. Check. If I were to calculate the gradient of the line, right? If I were to calculate the gradient of the line, I would say y2 minus y1 all over x2 minus x1, using this point here and that point. Remember, this formula applies when you have 2 points on a straight line. 2 points on a straight line, yes. So I would say maybe I can call this my x1, y1, then call this my x2, y2. So when I substitute there, I would say y2 is what? Is y. y1 is what? Is negative 8. And then my x2 is what? Is 1. My x1 is what? Is 0. What do we know about the gradient of the line? Already we know that it's equal to 1. So using this, we can then say we have 1 is equal to y plus 8 divided by 1. Therefore, if you multiply by 1 both sides, you have y plus 8 is equal to 1. Therefore, your y will be 1 minus 8, which means your y is negative 7. Interesting. Your y value is negative 7. It's not corresponding with that, but good people, it might be because I drew the graph wrong, but as long as we're getting the concept that this y value there would be belonging to that point, so therefore we know that that point there, the y value is what? Is negative 7. So we know that here it should be what? It should be negative 7. Obviously the y values are positive here, so that point means it's down there, right? it's probably down there, but it doesn't really change much of the concept. Okay, it doesn't change much of the concept. So now that we have that, remember what I said. If you substitute 1 into this formula here, what should you get as your answer? Your answer should be -7, okay, because that point belongs to all the graphs. So we already know that, therefore in terms of f, right, f of 1 is equal to 2 into 1 cubed, right, plus p into 1 squared plus q into 1 minus 7. So it means you will have your f of 1 being equal to 2 plus p plus q minus 7. Okay, so what does it mean? It means that you will have f of 1 being equal to 2 minus 7 is -5, and then plus p plus q, right? Now f of 1, we already know that f of 1 means, what is the y value when x is 1? The y value is -7, so we should put -7 there and say -5 plus p plus q. So if I take -5 to this side, I will have -7 plus 5, which is equal to p plus q. So what does it mean? It means that I will have -2 being equal to p plus q. I have two unknowns. I will call this my equation 1. Then I go and look for my equation 2, right? So to get the second equation, let's say to get the second equation, we are going to say, okay, in terms of the tangent, what is the gradient of the tangent? What is the gradient of the tangent? We don't know. But because the line and the tangent are perpendicular, we know that when you multiply their gradients, we should get -1. So the gradient of the tangent, what is the gradient of the line? We already know that it's equal to what? 1. So we're going to say times 1 is equal to -1. So therefore, the gradient of the tangent, when you divide by 1 both sides, you will get -1. Now that we know that the gradient of the tangent is -1, remember we can write it as derivative of f is equal to -1, because f prime of x means the gradient at a certain x value. So the gradient at a certain x value is -1. Wait, this is the gradient of the tangent at which x value? 1. So therefore, we say f prime of 1 is equal to -1. So the gradient at x is equals to 1 is -1. The gradient of the tangent is -1 at x is equals to 1. Okay, so now that I have this, I am going to say, I go back to the equation of f, then I say I'm going to find the derivative of that. So I'm going to find the derivative of f, right? So we are given f as f is equal to what? So we have f at x is equal to 2x cubed plus, let me write it here, 2x cubed plus px squared, and then plus qx minus 7. Okay, qx minus 7. Then I'm going to find the derivative of f. Remember, whenever you have the gradient of the tangent, you have to define the derivative of f, right? So the derivative of f would be, remember, 2 times 3 is 6, and then 3 minus 1 is 2. Then p times 2, that will be 2p, right? And then you have x, and then 2 minus 1 is 1, right? And then here the exponent is 1, so I just take the number in front, or the coefficient, which is q, and then the derivative of -7 is 0. Now remember, if I were to find, let's say I wanted to find the derivative at 1, I would substitute x as 1. I would substitute x as what? As 1, and then plus q. So therefore, the derivative at 1 would be 6 plus 2p plus q, right? But what is the derivative at 1? It's -1. So it means the answer that I would get here, right? The answer that I'll get here, this should be equal to negative 1. Okay, so what does it mean? I'm going to equate that to negative 1. So I'm going to say, therefore, since this is equal to negative 1, negative 1 is equal to 6 plus 2p plus q. Then I take the 6 to this side, I'll have negative 1 minus 6 as 2p plus q, right? Then what do we have? We're going to have minus 7 is equals to 2p plus q. Now I have my second equation. Okay, so remember, our first equation is this one, then this is our second equation. So I can make q the subject of the formula here by saying from equation 1, right, I can say negative 2 minus p is equal to q. I've made q the subject of the formula by taking p to that side. Okay, so I then say, therefore, this is my q. Then I substitute the q there, right? So therefore, negative 7 will be equal to 2p plus, where I see q, I put negative 2 minus p. Okay, so I will have negative 7 is equal to 2p, and then positive times negative is negative 2p, right? Negative 2, and then positive times negative, that will be negative, then I have minus p there. Then I will say 2p minus p, it's p, and then there's minus 2 there. Okay, then I'll then say then I'll then say I take p, negative 2 to this side, so I'll have negative 2 plus 2 as my p, therefore the p should be negative 5. So now that I have p, I can easily find q, right? So therefore I'll have negative 2 minus into negative 5 as my q, so therefore I'll have negative 2 plus 5 as my q, therefore q should be 3. Okay, so that is p, that is q there. So it was 8 marks because it's a lot of working out, isn't it? It's a lot of working out, but we just needed to interpret this. Okay, just to say, if I'm given this angle, what was the purpose of this angle? Was to help me to find the gradient of the line. Which line? The line that is perpendicular to the tangent. Now that I would have the gradient of the line, it would help me, number one, to get the missing y value there, here, right? It would help me to get the missing y value. Then number two, having this gradient of the line would help me to find the gradient of the tangent, because the gradient of the line times the tangent is negative 1 since they are perpendicular. So I would get the gradient of the tangent, right? Now, getting the y as negative 7 here, what does it help me with? It helps me to say I can substitute x as 1 into the equation, right? I should get that the answer that I substituted, this answer here, should then be equal to negative 7. That's why I say negative 7 is equal to that. Then that helped me to form an equation. And then here, getting the gradient of the tangent, what does it help us with? All the time, if you have the gradient of a tangent at a certain x value, because that is the gradient of the tangent at 1, right? So getting the gradient of the tangent at a certain x value, that the gradient is negative 1, helps you to say the unknowns in the equation of f, they will be able to be solved. Why? You would find the derivative first, then substitute x is equals to 1. This here, what you are seeing here, good people, let me circle it. What you are seeing here, since this is f prime of 1, you should get here as the gradient, the gradient of the tangent, where at x is equals to 1. So we already know that the gradient of the tangent at x equals to 1 is negative 1. That is why we equate this to what? To negative 1. Then we create the second equation. Then from that we can just solve simultaneously and find our answers. I hope that has given you all the information you'll need regarding tangents and then lines perpendicular to the tangent. That is how you always solve the questions. I think I went from at least a bit easy questions to the most difficult ones, isn't it? So I hope that that has given you all the knowledge you will need to ace those exams. Okay, so now we're going to move to some cubic function applications. All right, so yeah, stay tuned.